Okay, there was a question on the forum about how to create a model that was shown on Too Tall Tony's website where he does these modeling, speed modeling contest. And in particular, there was concern about or question about how to create this model and get this lofted feature in here on this arm. So what I'm going to do in this video is go through how I created the model, how I created the loft, and at the end I'll have a tip on how to get this dimension on the drill point at 10 millimeters from the bottom face. So to begin with, let me bring up my the first part that I modeled. Let me turn on some planes and the sketches, and I'll just roll this back to the top. So I started out with a sketch, and my first sketch is I have a reference arc or circle at 166 millimeters diameter drawn on the XY plane and located on the origin. From there I drew two lines tangent to the arc and coincident on the endpoints. Then I applied a symmetric constraint between the two lines and the x-axis, and I dimensioned those lines at 15 degrees angle and 120 millimeters long. Okay, and that coincides with the 120 millimeters from this endpoint or center point of the of this part of the model and the origin, and the 15 degrees on the slope of the arm. So with that set, I was then able to create a plane. Well, back up here. Let me go back in. While I was in my sketch here, I used the insert point from sketch option to select the endpoints of the sketch lines, and once I selected the point, then I clicked apply, and that created these green reference points on the ends of my sketch lines. So now those points I used in the first case here. I used the YZ plane and the point to locate a new sketch plane for the first ellipse, and then on the second plane I offset and created that off from the YZ and the end point at the 120 millimeter location for the end of the loft ellipse. Then in this particular model, I lofted between two solids. So I created my sketch on this first offset plane, located on the origin, dimensioned at 12 millimeters on the radius, so I get a full 12 millimeters across as a minor diameter. And then for the major diameter, I located the end point, or the quad point of the arc or ellipse, to the first reference point on the reference plane. Then my extrusion, I created that in the negative direction so that it's going away from the direction that the loft is going to be created in. On the opposite end, I created another ellipse or another extrusion on that ellipse, and again it's 1 millimeter thick, and it's going, in this case it wouldn't matter going either direction, because if it goes to the left in this case it would be going inside the loft parameters, because it ends up being smaller than the angle of the loft. Anyway, once that's selected, and I created the loft, selecting the two opposing faces of the solids, and then I had no tangency selected, and I deselected any minimize, curvature, or simplify, so that's just a straight loft between the two faces. And from that point I just went ahead and I started creating the rest of the features in the model. And what I ended up with was a total mass of 1,660.9 grams. Now, the correct answer is 1667 plus or minus 3. So I'm a little bit shy on the total mass of this part. So then I went to another part, or another model, and in this case I ended up with the same mass, but in this case what I ended up doing in my loft was still creating all of the reference planes and sketches, and my loft now is actually between the two sketches that in the previous example I created the solids from, but now instead of the extrusions I used those two sketches as the basis of the loft. And here I selected to minimize curvature and to simplify the loft. But to no avail, I still end up with, at the end of the model, I still end up with the same mass, 1660.9. So then what I tried next was, well, if I add more guide curves, I went back in and I had my top and bottom guide curves between the two separate sketches between, let me just get into a sketch here. I've got my end sketch, and the top guide curve is on the XY plane, and then it's just a line between these reference points. So I sketched the line, and then I placed a coincident constraint from the end node of the point or the line to the green reference points. And I did that for each top and bottom guide curve. And then on the front guide curves, I actually went in and I added more reference points on the reference planes, or the new planes that I created up here, and then constrained. Basically, they end up being a horizontal line from to go between each end of the loft, because the loft is going to maintain its constant thickness across the minor diameter of the ellipse. But even after all that, I end up with a mass of 161.4, still short of the 16667 that the final model said that they had. So on my final model, I was able to get to within tolerance. I'm at what, 2.5 grams now, so I'm within the 3 gram tolerance. And here I did that by just using a guide curve along the top and bottom, and with no minimize, select curvature, and simplify was deselected, and no tangency selected for the loft. And that gave me a total mass of 1664.5, so I'm at least within tolerance now. So anyway, that's how I created the model. The other thing that I want to point out here is this feature here, where they have a drill point of 110 degrees and the end of the drill point is 10 millimeters off of the bottom surface. Now, in the contest, the competitors were using a sketched profile that they did a revolve cut to get these 3 different diameters and the drill point angle into that feature. Now, what I did is I used the hole tool, and what I ended up doing, oops, I don't need a point here. Yeah, get rid of that. So what I ended up doing here was, as I put all my parameters in, I've got a diameter of 10 millimeters, I've got a drill point of 110, my depth of counterbore is 8, the diameter of the counterbore is 18, and then I'm calculating what the total length is so I can include my drill point. And the way I did that was first I hit on my drill angle or drill point angle, hit the FX, and then I choose that as a favorite. On my diameter, did the same thing. I select that as a favorite. And then on my depth, select that as a favorite, but then I come in here and I add this equation. I take my diameter, so my depth that I want is 56. If you look in the drawing, total length here, or total height is 66 minus the 10. I end up with 66 millimeters from surface to drill point. So I've got 56, and now I'm going to subtract my drill point. And I calculate that by taking my D21, which is my diameter, and divide that by 2. And then I divide that by the tangent of my drill point angle divided by 2. So it's basically 5 millimeters divided by the tangent of 55 degrees, and I get 52.499 as my total length for my depth. And what that gives me then, let me turn on a section view here. When I come in and measure this from the drill point to this surface, I got my 10 millimeters. So that's a little, that matches what my dimension here is. Now, the next step is I'm still measuring my hole diameter here is 10 millimeters. It's viewable down here in my readout. So the next thing I did was use offset face from my direct editing toolbar. So I select offset face, and I offset 1.5 millimeters, and that reduced the 10 by 3 millimeters. So now I have 7 millimeters on the bottom section of my drill hole. The only thing it's not going to do is add threads or code that for tapping. So that's something you have to, if you're going to put this in a drawing, you'll have to account for that if you use this little trick. But anyway, that gives me a hole tool that I can create 3 different size holes and a total depth measuring to the drill point rather than the bottom of the straight section of the drill. So hope this helps, and so if you ever need to create a part or drill a hole that's measuring the drill point rather than the drill depth, then hopefully you can use this little angle, this equation, to help calculate that for you on your to come up with a solution for your problem. So hope this helps. Talk to you later.